Please introduce yourself and briefly summarize your professional education and background.
So my name's Fred Gerringer, and I work for Brown and Caldwell as their national water reuse practice leader. I'm the office that I'm located at is Los Angeles in California, and I've been working in the industry about 25 years. I'm a product of the University of California system, so I did my undergrad at UC Berkeley, and then went to UCLA for a master's and a doctorate degree.
Okay, so water reuse national practice leader. What exactly does that entail? And what are some of the core things that you work on and deliver?
Yeah, so as the National Reuse Practice Lead, I'm the leader of our reuse leadership team. So there's, there are different leadership members in different sort of parts of the company. And so I help kind of coordinate the activities between all of them, make sure we're kind of all on the same page. I kind of lead Brown and Caldwell's brand representation in the water reuse market. So I'm kind of like one of the most identifiable people at Brown and Caldwell who's involved in water reuse. Also need to keep up on kind of trends and drivers in the market. My background, I've worked in California for most of my career. So I took on this role about a year and a half. Well, I took on a national role at Brown and Caldwell about a year and a half ago in this particular role several months ago. And so I'm kind of broadening my focus and looking at more of the country rather than just California. And then it's, aligning kind of strategic planning with goals within the business units, helping develop internal technical capabilities in the water reuse space and driving the execution of, high quality execution of reuse projects.
Okay, that sounds like quite a bit. But you've also been working on this other important project, the State Water Reuse Regulatory Guide. Could you describe what the guide hopes to accomplish and what you've been doing to help? And why is this guide unique compared to previous resources along these lines?
Yeah, so the State Water Reuse Regulatory Guide project, that's a project that was started by the Water Reuse Association. The Water Reuse Association is like the largest advocacy group that's focused just on water reuse in the United States. And so they got together with some of its partner agencies. So that's the American Water Works Association, the Association of Metropolitan Water Agencies, the National Association of Clean Water Agencies, and the Water Environment Federation. So they got together with them and decided to put together this or try to get this project moving. So they put out a request for proposals from different consultants, and they selected us as the winner of that selection process. And so what the guide is hoping to do is really to be a resource to the Water Reuse Association, its section members. So the Water Reuse Association has various state sections across the country and a couple other sections that include multiple states. And so it's to support their section members as well as those partner organizations for the development of reuse regulations in their states. And that's why it's with reuse regulations, it's important to keep in mind that it's really regulated at the state level. It's not like drinking water and wastewater that are regulated at the national level, and then states kind of do some things differently depending on what they want to do. This is more kind of at the state level, regulated state by state, and so the regulations in states can vary quite a bit. And so it's to help those different organizations kind of navigate the regulatory development process within their states. And so that's it's actually a significant challenge because the kind of regulatory structure varies in states. It's not the same everywhere. What regulatory agencies are responsible for different part of regulations and their development, who's protecting groundwater, who's protecting discharges to the environment from wastewater agencies, things like that varies a lot by state. And so this guide is at a high level, going to help those different organizations kind of navigate the process, understand what are the priorities, the concerns of regulatory agencies, and then help them address those concerns and engage with the regulators to develop regulations that are protective of public health, achieve their objectives from a regulatory standpoint, but then also are implementable and allow projects to proceed.
Okay, so with the complications of it being, all the different states, does the guide go into details on like, is it broken up state by state and here are your regulations, or does it provide more broader guidance and says, consult your local state's regulations and ordinances?
It's more broader, so higher level and bigger picture, focusing on kind of the different phases of regulatory development and how interested agencies can engage with the regulators at those different phases. Because the specifics within states can vary so much, it'd be really difficult to give specific advice because you would kind of need 50 different guides if you're going to do that, right? So yeah, it's higher level in focus, but there are common stages to regulatory development. We're also looking to identify the technical building blocks that need to be included in regulations when they are developed. It is looking to support both potable and non-potable applications, so it's not focused just on one or the other, but it's broad enough to apply to both, regardless, or really any water reuse application. So there's kind of to the guide, like I was saying, it is high level, and it's really focused on helping with the regulatory development process, understanding the actions you need to take with the regulators, how they want to be engaged. So as part of this project, we have already had 2 focus groups where we've actually spoken to, I think the first time is probably around 30 or so regulators, and then the second time about 20. So we had these 2 different focus groups to kind of get their input on what's most helpful for them when you're going to be engaging with them. What are the types of challenges that they face, so that if you're a water agency and you want to have a reuse regulation developed in your state, you can better understand their perspective on things, the limited resources that they have, and maybe what can you lobby for with your state legislator to provide them with the resources that they need in order to develop a regulation effectively. There's also the developing, the building blocks for that go into kind of the technical components of the regulation. You need to decide what are the health goals that you're trying to achieve, when you're talking about protecting public health. What source waters are you talking about? What are the treatment technologies that you need to kind of bridge the gap between what your source water quality is and your finished water quality? And then what kind of things do you need to think about when these systems are actually up and running to make sure they're operating properly, that there's proper reporting on that, and checking to make sure that they're performing as intended. And we're not, in the technical side of the project, we're not looking to come out with recommendations saying you should do this, you should do that. It's more providing examples of what has been done, what has worked, and how those could be applied in different situations. So not trying to be, kind of force fit one solution on all states, because as we've seen from the development of regulations across the country, each state does take, for the most part, a slightly different approach. Some of them are quite different. And we're trying to develop a guide that supports that, but still allows the flexibility for states to do what works best for them.
All right, I think that's a great explanation. I know that our audience, they like to see what others are doing and make their own decisions and not be kind of told what to do, but just to be guided and provide some insight. So this is a high level and kind of a general guide. Can we take a step back and give some background on what the water shortage problem is and how water reuse and what water reuse is, and that might be part of the problem to shore up some of the water shortage issues?
As probably many people are aware of, we have a society with, aging infrastructure. We have a growing population. We have increasing, demands on our water supplies for various purposes. Some of it for economic reasons, right? Data centers are something that gets mentioned a lot. They need cooling water to cool off their systems there. There's also environmental purposes, right? We prioritize the environment much more now than we did decades ago. And so making sure that we're leaving enough water in the environment so that ecosystems can thrive and organisms can live as they should, that's also a focus. And so we need to leave some of the water for the environment. The changing climate, of course, that we're all experiencing. That's a challenge where plans for the development of water resources that were made decades ago don't necessarily apply anymore. An example is the Colorado River, right? That basin, the reservoirs there at historic lows, they've been that way for a while. There's no expectation that they should change anytime soon. That creates challenges for long-term planning and, water reuse. That's one reason why water reuse in the Southwest and California and other areas is becoming very, very popular there. And particularly pushing into more and more potable reuse is because of these scarce resources that we have, the droughts that we've all experienced, the lack of water in the Colorado River Basin and in other basins that we've seen in recent decades. There's also, and going back to the Colorado River, right, there's challenges going on right now with creating a long-term sustainable agreement there that the basin states that are affected by that, are going to be able to have for long-term stability in their water use. And then, going around the country, there's water scarcity, right? But there's also nutrient limits that we're running into, temperature limits, basically wastewater discharge limits, right? That are getting increasingly more stringent and difficult to comply with. And so those limits can drive alternatives to just discharging the water to the environment. And so in addition to the scarcity, you might be able to actually beneficially reuse the water. And instead of putting it into a water body or having to treat it, so you have to get to really low nutrient limits to put it into a water body, you might be able to treat it differently and then reuse it for either recycled water for non-potable purposes or for potable use. And so there's a lot of different drivers around the country. It really depends on where you are, the kind of drivers that pop up. But we are seeing these in a lot of different areas, in areas you wouldn't expect. Even some relatively water-rich areas are looking into reuse because of kind of the nutrient discharge limit drivers and things like that. And so then where water reuse can help is because it really, it gives you a different source of water and a different place to put the water. So water reuse is considered a local supply. It's not something, I'm out in the West and we have to import a lot of water. We bring it in from other areas because where the water is and our population centers oftentimes aren't in the same place. And so when you have to bring that water from a long distance, that's expensive. And then you get affected by climate conditions a long distance away that can affect the availability of water to you. But water reuse gives you that local control, a local supply that is produced locally and controlled in that area. It can also be a hedge against natural disasters. In California, there's faults, the San Andreas Fault and others. Earthquakes could affect the conveyance system for a lot of the water that's brought in here, just as an example. So if there ever happened to be some kind of catastrophic failure there, water reuse provides local resiliency to issues like that. It also has the advantage, it depends on how you use it, but if there's lots of projects that take this potable water, once it's been treated to potable water standards and put it in the ground, and then it can be stored there for later use. So you don't need to use it right away. So it provides water storage. So if there is drought, there are other shocks to the water supply, it can help reduce the impact of those shocks. And then, kind of getting back to what I was saying before, with regard to some of the other drivers about discharges, is it gives you somewhere else to put the water, so you're not having to discharge it into environmental water body, right? You can now take that, use it for a beneficial purpose. So you take that pressure off in the environment, but then you're also getting a benefit out of it at the same time.
Okay, it seems that water reuse is a loose definition. What are some of the ways that are good examples or some common examples of what water reuse really looks like? Some of the best cases that people are doing now, some things that you might like to see in the future, but like just so we can fine tune a little bit of what water reuse really means.
So water reuse, there's a lot of different kinds and types of water reuse. So there's two big categories, are non-potable reuse and potable reuse. So non-potable reuse are all those uses that don't introduce it to the public's drinking water system, basically. So that would be something like, golf course irrigation, or being used for industrial purposes, like a cooling tower in an industrial process. So those are non-potable reuse type applications. And then you have potable reuse applications. So that's like when you take the water, you treat it, and then it gets put into the groundwater system. And so it's not going directly into, the drinking water system. We call this indirect potable reuse because it's going into an environmental buffer, which is like a groundwater basin or a surface water reservoir. And it goes into that environmental buffer and then stays there for a period of time. Excuse me. And then there is also what's called direct potable reuse. So direct potable reuse is where the water is going into more directly into the distribution system. And this is not something that's currently practiced in the United States. There are certain parts of the world that do this, but we are doing, actually, that's not true. There is one project in Texas, Big Spring, Texas, that is doing a form of direct potable reuse. But that's the only one. And there's one in El Paso that is looking to do what's called treated water augmentation, which is direct potable reuse that goes directly into the drinking water distribution system. And so that's another type of application of potable reuse. And interest in direct potable reuse that I just talked about is growing. There's a lot of projects in kind of the Southwest that are looking to that as a potential future water supply. So over the coming decades, it'll be really interesting to see kind of the projects that move forward to provide drinking water directly to customers in that way.
Okay, those are some great examples. Could you describe perhaps one example, like in specific details, that kind of shows, where the water comes from an origin point, it gets used the first time, what process may have to happen, the transport, the cleaning, if you will, in order to get to another reuse? Just maybe walk me through a favorite example of yours that's pretty descriptive and general.
Probably the best known water reuse, potable water reuse project in the United States, and that's Orange County Water District's groundwater replenishment system. And so that's located in Fountain Valley, California. And Orange County Water District has a partnership with Orange County Sanitation District. And so the Orange County Sanitation District has a couple of wastewater treatment plants that are down near the coast. They treat the wastewater, and before this project came into play, all of that wastewater, after it was treated, was discharged to the ocean. And Orange County Water District got in a partnership with Orange County Sanitation District to develop this indirect potable reuse project. And so the sanitation districts provides the wastewater treatment, and then a portion of that flow goes to the Orange County Water District. And they have built a wastewater or advanced water purification facility that treats, I believe it's 130 million gallons per day. That's its capacity. It uses low pressure membranes, so microfiltration membranes. It uses reverse osmosis to remove salts and other organics. It uses advanced oxidation with UV and hydrogen peroxide to oxidize organic contaminants. And then there's product water stabilization on the back end, because once you go through reverse osmosis, there's very little, if anything, left in it. It's very corrosive, the water is, so you have to put calcium and other constituents back into it to stabilize it. And then that water goes and is injected into the ground. or they also have surface spreading basins. So they put it in a couple different locations into the ground, and then it stays under the ground until it is pumped out for use. And an advantage of this project you're talking about, kind of the conveyance aspect of it, is the Orange County Sanitation District wastewater treatment plants and this advanced water purification center are basically right next to each other. So it makes for very short conveyance between the two. And that's actually, there are many projects that try to co-locate like that because there are a lot of advantages to it. It allows the advanced water purification facility to send its waste back to the wastewater treatment plant. And there's other benefits too. So that's kind of the general layout arrangement of that project.
Okay, I think that's a big help. It really explains the way that it uses piece by piece in there, and also with these interviews, I really like to give those I'm talking to a chance to offer their advice to their colleagues and those who are in their same field but maybe haven't dived this deep into what you're doing. So other than to obviously go out and get the state water reuse regulatory guide, what's some advice that you would give that maybe a lot of engineers aren't thinking about in the water field that you could quickly pass on to them, like, hey, as you're working on your projects, maybe think of this or something that you've come across that you find very useful that maybe isn't as well known or understood as it should be?
In our industry, like water, so drinking water and wastewater are really kind of well established. I think something that's interesting about water reuse is it's really growing. It's relatively new, particular potable reuse. And I think one of the cool things about water reuse projects and working in this part of the industry is that you get to be involved in a lot of kind of greenfield type projects. Like you're building new things, you're doing new stuff, whether you like doing pipelines or treatment plants or whatever is the type of thing that you like to do. We're working with kind of all new things. Whereas a lot of other aspects of the industry, a lot of times it's rehabbing existing facilities, upgrading, those kinds of things. So I like the fact that it's you're dealing with greenfield projects, and I think that can be exciting to a lot of people that who may not realize it. That if you want to be someone who kind of like, hey, I remember when that was built. You have an opportunity to kind of put your flag in the ground, or so to speak, with projects like this, because you can be there early on, you can be there at the beginning, and I think that's one of the most rewarding parts of these projects that I've been involved with is seeing some of them. When we work in this industry, you work on a project, and then a lot of times you're not able to see it from start to finish, but you are able to see it when it finishes, and it's this new thing that you played a role in. And so I think that's really rewarding.
That makes a lot of sense to me. Is there perhaps a piece of like engineering advice, like a bit of a technical aspect that you know of that you guys are able to be using, but maybe not everybody out there, maybe people that don't have as big of a water reuse problem like they do out west, maybe just a simple engineering tip that you could pass along that, hey, consider this the next time you're working on a water project?
I would say to really keep open to the possibility of water reuse. I don't, it's not going to be, it's not for everybody. It's not for every situation, of course. But I think there are clients who could benefit from it, who probably don't realize it, who don't understand the benefits that it can provide to them and their communities. And so I really just encourage people to talk to people like me, other experts in the reuse field, and really broaden their perspective a little bit and see what's possible, because there's a lot of challenges that are out there, and water reuse can help mitigate some of those. And I just think it's something that should be looked into and sort of included as a tool in the toolbox more often than it is.
All right, I think that's some amazing advice, because yes, just because you're not like in a life and death water situation doesn't mean that, a little water reuse can be beneficial to your clients, to the greater world, and to all those things. So, that's all I think I've got prepared to talk about. Fred, is there anything in our discussion that you feel like that we've missed that you really want to make sure we include in this interview before I stop recording?
On the state guide, we are partnered with Hazen and Sawyer, and their contributions are an important part of what we are doing. They're a environmental engineering consulting firm like us, who's also focused on water reuse. And I actually used to work for them. That's where I was before I started working at Brown and Caldwell. And they're making some significant contributions to the guide. They have a lot of water reuse experts that are contributing to the process, and so we're just grateful also to have them on the team helping us, deliver this project for the Water Reuse Association and their partners.